Okay. Okay. So today's topic is logical volume management. In short, it is LVM. It is one of the very important concept in Linux. Okay. What is the why? What is the reason? For what is the significance of LVM? We'll see. So for a Linux system admin, it is very important to manage the disk space. Okay, generally running out of disk space is to be start of a long and complex series of tasks. Like if the if the disk space is over, wait a second. Okay, so generally if disk space is over, then the task for the admin is system admin is again he will check for whether new partitions are available or not. If new partitions are not available, then he will go with new hardware, new hard drive. You need to add new hardware. All this activity is generally offline activity. Offline activity means you need to bring the system down. After that you need to add new hardware, and you need to boot that system into either recovery mode or single user mode. After that you need to create a new partition, and you need to after that partition you need to apply file system on that new hard drive or new partition. Again you need to mount it temporarily and permanently as well as. Okay, after that you need to change the content from slash etc. Okay, you need to again you need to give it mount it. After mounting, rebooting, you need to reboot the system. All this is a series of tasks. If disk space is over for a server, for a system, then the system admin need to follow all these things. And also that is an offline activity. That means you need to bring the system down, then only you can do it. And you need to unmount that if there are some mount points are there, you need to extend that mount points. It is a difficult task. And also regular standard partitions are having some drawbacks. So if you do partitions in a standard partition format, there are some drawbacks. What are the drawbacks? Are nothing but we can do a maximum of 3 primary partition and one extended partition. In that one extended partition, again we will do logical partitions according to our requirement. But the problem with that one is, if you do like that partitions, if you want to extend a mount point based on our requirement in future, if the requirement is changes, then we cannot extend that mount point in a regular standard partition. And also we cannot shrink. That means we cannot decrease that mount point. That means the size of that mount point. Suppose let us consider, if the size of some mount point is some 2 GB, suddenly my requirement of space for that mount point increased. Then I want to increase it by 1 GB, one more 1 GB. But in if you do that by standard partition, you cannot do that. In the same way, if you want to shrink that, that means if you want to decrease that 2 GB to some 1.5 GB, like that, again that is also not possible for a standard partition. Of course, this is up to extra ext4 file system only, up to RHEL 6 only. In that case, we'll go with a new concept, that is nothing but Linux logical volume manager, nothing but LVM, where we can grow or shrink and move those partitions from one drive to other drive as our requirement. Okay, it can create a virtual disk partitions. Okay, it can add one partition from one disk and another partition from another disk to a same single mount point. That means it will create a virtual it will virtualize the disk. It will create virtual disk partitions out of one or more physical hard drives. And also we can so that we can grow means we can increase or we can decrease or we can move one partitions from one drive to other drive based on our requirements. Okay, it also you can create larger partition than you could achieve through a single hard drive. Suppose if you require so some 500 GB, but we are having 200 GB hard drive. Let us say uh, for our mount point, if you require a 300 GB mount point, but we are having 200 GB to 200 GB, two hard drives are there. So if you do that by standard partition, we can achieve only 200 GB for that mount point. If you use LVM, we can take 200 GB from one hard disk, we can take 100 GB from other hard disk. Of course, that is not a regular criteria. We'll take according that performance of the drive. We can take 150 from one disk, we can take 150 from other disk, like that also. But it will allow the virtualization of the disk partitions. That means we can take one partition from one hard disk, another partition from another hard disk, and we can combine both of them and to make a single mount point. That is advantage of logical volume, LVM, logical volume management. That means we can increase or decrease, we can move partition from one drive to other drive, whatever you can do using LVM concept. This is one of the very important concept. Okay, so look here, in this diagram you can understand what is an LVM. Okay, this is totally, this diagram explains the logical volume management. Okay, concept. Here if you see hard disk, generally hard disks are suppose these are SCSI, let us consider. Okay, so /dev SDA is one hard disk, is second hard disk, second third, some hard disks are there. Okay, we can make those hard disk, we can make some partitions on those hard disks, like SDA1, SDB2, some SDC2, SDC3, like that. There are some partitions are there. We will make these partitions as some physical volumes. Okay, of course partitions, or we can take the entire disk, entire hard drive as a single physical volume, or some partitions from the hard disk as some physical volumes. All these physical volumes are combined to add these are added to a single volume group. Combinedly these are all called single volume group. That means just like physical volumes are nothing but hard disks are there may be complete hard disk or some portion of that hard disk. These all hard disks are added, and we will make them as physical volumes by using a command pvcreate. After that these are all added to a single volume group, big size by using command. Okay, after that after creating this vz, again we'll take whatever, we will make some logical volumes according to our requirement. Suppose for example, on this SDA I'm having partition size is 10 GB. On this I'm having 20 GB. On this we are having 15 GB. Again on this we are having 15 GB, 15 GB, 15 GB. Again on this we are having 10 GB. So combinedly 30, 40, 60 and 70, totally 70 GB is available from all these hard disks. Let us consider all these combined to a volume group. So totally it is 70 GB, of course from different hard disk. Please understand that concept. Here physical volumes are different, physical volumes are there. All these combined to logically as a volume group. Got that point? Logically these physical disks are combined by using a concept volume group. Let us consider these are having some 10 GB, 15 GB, 20 GB, 15 GB, 15 GB, 10 GB. Let us consider all these combined, we will get some 70 GB. Now if I require for a mount point, let us consider it is the mount point name is OPT. Of course we are having a lot of mount points in Linux. Okay, OPT, for OPT I require some 40 GB. Let us consider for this OPT I require 40 GB disk space is required. So if I check on this, I am having 5 hard disks, but all these 5 hard disks I'm having some lesser GB. On this I'm having only 10 GB partition. Let us consider only for example. Here I am having 20 GB on second disk, here I am having 15 GB, here I am having 15 GB, here I am having even 10 GB. But here per OPT I require some 40 GB of space is required. What we need to do is, these are physical device, we cannot combine those to give 40 GB. Where this LVM plays an important role. These all physical partitions are considered as a physical volumes. All those physical volumes are grouped together, then they constitute a group which is known as a logical group, which is known as volume group. Okay, of course these partitions are physical, but all these physical volumes are combined logically to create a volume group. Let us consider here some 70 GB is available from all these are combined, then it is a 70 GB space of volume group is created. Out of the 70 GB, for OPT I require some 40 GB. For that I will create a logical volume LV1. Okay, LV1 with some 40 GB. From that 40 GB we can mount this OPT. Okay, if you do that by standard partition, if you want to mount this OPT, if it requires 40 GB, then you need to go with a new hard disk, because out of all these hard disk we are having less space. Here 10 GB, here I am having 20 GB, suppose here 15 GB. So a single hard disk doesn't provide that much space in our example. In that case, we will combine all these physical volumes to a volume group. Okay, later that was made as a logical volume of whatever space we require. Okay, based on that logical volume we will mount that mount point according to our requirement. We can create one more logical volume LV1, LV2, like that. After that there is some space available. If you require that space again, in future, if I need some 10 GB, I want to extend this OPT. At present I am having 40 GB on LV1. Again I can increase that 40 GB to 50 GB based on this free space, so that we can increase. And if you want to decrease that space also, we can decrease that. There is advantage of logical volume. That means this what this logical volume manager will do is, it will create virtual disk. That means it will combine all the physical volumes and make a logical volume group, big volume group. That volume group is logically, it will combine all the physical volumes, and from that volume group we can create some logical volumes according to our requirement. Those logical volumes are those logical volumes can increase or decrease, can move from one group to other group easily. That is the main advantage of logical volume group. So how to do that, how to create a logical volume? Here this is the important thing, how to create logical volume. The first step is here these things, basic hard disk is, partitions, how to make partition is, from the partitions you will make a physical volumes. How to create a physical volume is pv, simply it is called pv, by using some pv create. After that these physical volumes are combined to make a big volume group. From that volume group, by using this vz create command, from that volume group we can create a lv according to our size, based on that lv create command. After creating that lv, we'll format file system. Okay, as ext3 or ext4 some file system. After formatting that logical volume, we will mount some mount point to that logical volume. That is the concept. Okay, first we will have hard disk, and on the hard disk we are having some partitions. We need to make some partitions. Those partitions are while doing that partition we need to change the hexa code to LVM, that is 80. Hexa code for LVM is 80. Those partitions are based on those partitions we will create physical volumes. Those physical volumes are combined to a single group, that is nothing but volume group. So volume group generally has some big size of amount of data. Out of those volume group, we will create logical volumes according to our requirement. The main advantage of these logical volumes are these: we can increase, we can grow or shrink, or we can move these logical volumes from one to another. That is the advantage of LVM concept. Okay, I'll tell you one by one. Okay, So how to do that? So before going to do that, what are the general components? So some terms you need to know is, first one is physical volume. It is nothing but it is the standard partition that you add to the LVM. So combinedly, just now I have shown this diagram now. Combinedly, this is entire portion, the entire block diagram is known as LVM. Okay, in that LVM we're having the first stage is PV, physical volume. So it is PV is nothing but general some portion of hard disk. It is a standard portion. This standard partition, this standard partition is made as physical value by changing its X code. You know how to change X code. You have seen that in a swap. Okay, I'll show you how to change that one later in the practice session. By changing it to 80, we can make a standard partition to physical volume. So physical volume may be combinedly a hard drive, a complete hard drive, or some portion of that hard drive according to the space available and our requirement. Next, what is physical extent? Physical, I will show practice session. I will show everything. What are these? You will understand clearly. P, physical extent. It is a chunk of disk space. Every PV is divided into some number of equal sized PVs. I will tell you clearly when a PV is created. I will show what is this P is. Simply P is, it is a PV is divided into some number of equal sized P's. That P is nothing but P. That is nothing but physical extent P. Okay. Next, what is volume group is, just now you have seen, it is composed of group of PVs and LVs. That means what this volume group is do is it combine PVs and map to LVs. Okay, it is the organizational group of LVM. Main, this one is main thing, middle between PV and mapping. It will map PVs to LVs. Okay, LV nothing but logical volume is composed of group of LEs. Okay, you can format and mount any file, just on it on an LV is logical volume, just like it is physical volume is nothing but some partition or some portion of disk, nothing but some partition. We that physical portion is nothing but just like a standard partition. Now that concept is changed to LVM. Those standard partitions are combined to create a volume group. Out of that volume group, some logical volume we will take. Okay, that logical volume is that may be from a single hard disk or some number of hard disk, some portions of that hard disk. That is known as logical. That is, that volume is logically we have taken. Okay, it is composed of group of LEs. LEs means logical extension, just like PEs, it is LEs. I will show what is LE. The size of these LVs can easily be increased or decreased as per the our requirement. Mainly, this is the advantage of LVM. Logical volume concept is. That's why we need to learn this concept. Next, logical extent. It is also a chunk of disk space. Every LE is mapped to a specific VA. Okay, LE is nothing but it is every LV is divided into some equal number of LEs. Okay, every logical volume is divided into some equal number of logical extents. So those are called LEs. Okay, logical. So every LE is mapped to every PE. Okay, I will show you at the practice session. Now, how to create a LV? So before creating LV, we must create a volume group. Before creating a volume group, you must create a physical volume. Okay, if you want to create a physical volume, you must need some partition on the hard drive. So the steps are, if necessary, install a new hard drive. If already some disk space is available, some partition is available, then no need to install go with the new hard drive. No need to add a new hard drive. If space is not there, then if necessary, then you need to add some new hard drive. Next, create a partition on the hard drive. If you need some portion of that hard drive, then you need to create partition. Or if you want to add the entire hard drive, then you will consider that entire hard drive as a single PV. That is optional according to our requirement. Okay, if you require that 300 GB of LV, if entire hard disk is 200 GB, then no need to do partition on that one, because 200 GB and 100 GB from another hard drive can be combined to make 300 LV. In that case, no need to partition. You need to partition the second one as 100 GB. Okay, so that is also option. You can create a partition, or you can use the entire hard drive based on your requirement. Okay, next, of course I will partition here. I will show in the lab. Okay, next third step is create a physical volume of the complete hard drive or a partition on the hard drive. Next, you will create a PV. Okay, PV of complete hard drive if require complete hard drive or portion of the hard drive. Simple. It is just like the procedure is just like your standard partition, but only the difference is you need to change the hex code of that partition type to 80. If standard partition, the hex code for that one is 83. Now it is, if you want to add that to LVM, you must change that hex code to 8E. Okay, 8E. Then PV will be created. That portion is added to, you must add that partition. You need to make it as PV by using PV create command. I will show you how to do that. After making that PV, you need to add this physical volume to some existing volume group, or you can create a new volume group. Okay, next, yeah, after making a new volume group, what your task is, you need to make a new logical volume. So next you need to make a logical volume from the space available in volume group. Of course we don't need to use the entire volume group. According to your requirement, whatever you require LV size, that much we will take from the volume group by creating an LV. So for that you need to use LV create command. After creating that LV, you must access that LV. So for that you must create a file system on that LV, new logical volume. After that you need to mount that file system. It is just like a regular partition, regular mounting of a mount point. Okay, this is similar to that previous thing. After that, if you want to make it permanent, you need to add it to /etc fs tab. Okay, that is the procedure. We'll came one by one. So first what we need is you need to create a physical volume. So already I told you, first you need to create a partition, or you can use entire hard disk by using fdisk. After that you need to change that hex code to 80. Okay, after that you need to change and save that partition. You need to exit fdisk. After doing the partition, you must update to know the kernel whether the new partition was created by using this partx-a command. This is, it is just like a regular partition. After that you need to create PV, only new created partition. Suppose let us consider it is /dev some sdax. Okay, x means any number 1 2 3 whatever it may be. After that verify whether that PV that was created or not. Okay, before there are some PVs or not. Okay, after that to create a new partition, you will use this command pv create that partition name. Suppose here the partition name is /dev sdax. So pv create /dev sdax. So the PV will be created. So to know whether that PV was created or not, you can use pvs command or pvdisplay command. If you use pvs command, it will show. I will demonstrate at the time of practice. Okay, if you want to know the entire only about that PV, you need to use pvdisplay, or you can use pvs. If you use pvs, it will show and all the PVs. If you use pvdisplay with that name, it will show this entire. I will show you. It will show all the details. Okay, next, after creating PV, you must add that PV to the new volume group. If it is new volume group, you need to create new volume group, and that will be PV will be added to that. Okay, so to create a new volume group, vz create, name of that vz and partition name. Suppose for our PV is sdax, some sda1 or sda2, that will be added to by creating. First we need to create vz create. Suppose my volume group name is my vz. Here this is a name optional based on our requirement. Okay, we will give whatever name we want to give to that volume group, my vz, for example, my vz. And just now I made some pv, I have created a new pv. The pv partition name is this one. We will mention every time pv by that partition only, but it is not just like a standard partition, it is a pv. Now this pv it will be added to this vz. That means I have created vz with some physical volume, okay, by using vz create. After that, check whether that vz is created or not. So by using this command vgs or vz display, if you use vgs, it will give all the vgs information uh, in the system. If you use vz display, that vz name, it will give the information about that vz only. Okay, we'll see one by one. After creating vz, first we need to create pv. After that we need to create vz. Okay, after creating that volume group, then we need to create lv according to our requirement. Okay, so suppose if you want some lv some size, we need to create lv by using lv create by hyphen space hyphen or minus capital L and size of lv. How much size of lv you need, you need to mention that size hyphen n. You need to mention the name of that lv. Suppose here in this case my lv. Okay, you can create lv1 lv2 or some lv. Okay, like that. And after that you need to create from where you are creating this lv, from which volume group. So here my volume group is my vz. From this volume group I am taking this lv, I am creating this lv. This is a syntax for creating lv. Of course there are different syntax for lv creation also, but here this is the one of the standard regular used one. Based on the size, we'll create lv like this. lv create hyphen capital L and size of lv hyphen small n and the name of the lv and volume group from which we are creating this lv. Okay, so after creating lv, the task is not over. We must access that lv. We need to create some directories, we need to create some files, we need to read that files, we need to write content into that file. So for that, what we need to do is you must format that with a some file system. So it may be some ext4 ext3, whatever our required file system. So for that, you know how to format uh, a partition using file system. For that we use command mkfs.ext4. Suppose for example in our case it is ext4 system, mkfs.ext4, and which lv we need to create. So now onwards the lv is named like this slash dev. It was created in slash dev slash vz name slash lv name. You need to mention after creating an lv, every time you need to mention the lv like this only, slash dev slash vz name slash lv name. Okay, so this lv was formatted using ext4 file system. After formatting this lv, treat just like lv is just like a partition, but this is logical partition, logical volume. Okay, next after that we need to mount that lv. Why we need to mount it? You need to access that lv. You need to create or write something into that lv. For that we need to mount. That means mounting is nothing but you need adding a directory to that file system, so that we can attaching a directory to that file system so that we can easily access it. So mounting an lv is exactly same like a normal partition, like that only, but here the lv is mentioned like this slash dev slash vz slash lv. Okay, how to mount? Temporary mounting is mount the device name. Here the device name is lv is the name. So slash dev vz name lv name, and for which directory you want to mount this lv, you need to mention this one. Suppose it is opt slash opt. Suppose it is some hyd directory, you need to mention slash hyd. Suppose it is some slash root some slash test directory is there, you need to mention that like this, mount lv name and hyd. So every time lv name means it will like this only, slash dev slash vz name slash lv name. Like that you need to mention every time lv. If you want to mention lv, you need to mention vz and lv also, like this. Okay, that is the syntax for lv. Okay, after mounting it, it is just temporary mounting. If you want to make it permanent, you can make an entry in /etc fstab. Okay, if you want to see that whether it is mounted or not, you can verify this that using mount command or df-h command. This is just like ordinary partition. Next, after creating that, how to extend this volume group we'll see later after completing this practice session. Okay, I'll show you how to do that. Now start with one by one. So first, to create an LV, you must have some existing volume group, or you will create a new volume group. To create a new volume group, you must have that volume. You must have some physical volumes added to that volume group. So first step is, whenever you want to create LV, first step is you must create a PV. That PV is added to existing volume group, or you will create a new volume group with that PV. After creating that volume group, you must create a LV. After that, LV is formatted using file system that is later mounted using some mount point. Okay, first check whether there are some LVs are there. To check whether LVs are there, existing LVs, there are no LVs. Check whether there are some VGs are there. Of course, there are no LVs, so VGs are also there. No VGs, PVs. To check PVs, existing LVs, PGs, PVs, you use this command. Okay, no PVs are there, no VGs are there, no LVs are there. So I'm starting fresh. Okay, now to create PVs, a PV, first you must create a standard partition. Yeah, after that standard partition is converted into logical PV by changing it to Xcode to 80. That after that you will create that PV by using PV create command. Okay, you can take the existing partition as a PV, or you can create a new partition. First of all, let us check what are the partition I'm existing on SDN. Already I'm having these three partition. I'm not going through this. I'm having one more disk. SDB is also there in my storage. SDB is there. I will make some partition on this. I will make that as PV. So you know the procedure. fdisk, like a standard partition only, /dev SDB. So you will get a menu like this. M. To know the commands, you will press M. Okay, to print what are the partitions. Of course, I haven't made any partitions in SDB right now. Of course, previously I have created some, and after that I have deleted them. So at present no partitions are there. Now I want to make some partition. So to make a new partition, N. Of course, you can make new partition. Of course, if there is some existing partition, you can use that one also. Okay, so I want to make some PRE. Okay, it is asking for some partition. Of course, I'm taking it as first partition. So I want a PV with the size of 1 GB. So it starts with cylinder 1. Of course, you can start anywhere, but it is better to take the continuous partitions. You can easily remember. So I need some 1 GB. So for that I am giving plus 1 G. Okay, plus 1 G. Okay, so now check whether it was created or not. Okay, of course it was created with 1 GB. Okay, next what we need to do is you must change the type of the partition as LVM. So to change the type, you must use this T command. Change the partition. Now I am using T. It will because I am having only one selected partition, it will do that for one. If I am having 2-3 partition, it will ask for partition number. So Xcode. So I don't know. Actually, I forgot the Xcode number. Then to list the Xcode numbers, use L command. So here it will list all the Xcode numbers. If it is extended, then it is 5. It is standard partition, it is 83. It is Linux swap partition, it is 82. What I require is, it is LVM. Okay, so here it is 80 is LVM. I want to add this PV to LVM group, so I need to make the type of the partition as 80. Okay, look here, it is a standard partition. Just now I have created. I need to change this standard partition to LVM partition. So uh, I'm giving 8E to the partition 1. Now the partition 1 was changed to 8E. Okay, now check here, it was changed to 8E. Now after that, you need to quit from this menu with saving, writing that to partition table. So simple W. So what was now I need to update this by using partx hyphen a. So the partition name is /dev stb. So it was updated. Now just I have created a partition with LVM Xcode. Now I need to create a PV physical volume by using pv create command. So here my physical volume name is /dev stb1. Okay, before changing Xcode to the Xcode of this dev /dev stb1, it was a standard partition. Now I have changed that partition to 80 LVM. So simply by executing this pv create on this partition, then it will become a PV. So PV was created. Of course, there is something. Okay, previously I have created it as a swap. I have made it a partition as a swap. It is asking whether to wipe it off or not. Okay, it was successfully PV created. Check whether the PV is created or not using PVS command. This PVS command will give what are the number of PVs we are having, how many number of PVs, and what are the names, in which volume group it was created. Of course, now right now I have not added this PV into VZ, so it is empty, and it will tell the type of LVM. We are having LVM2, LVM3, LVM at present LVM4 is running. That means it is versions of LVM. These are attributes, we will see later. Size of that PV 1 GB almost. How much it was utilized? Nothing was utilized, so totally it is free, that PV size. If you want clear description of that entire PV, just use pvdisplay command, and here the PV name is /dev /sdb1. okay, you must mention. If you use pvdisplay command, it will give the entire details of that PV /dev. Look here, the PV name is SDB. Of course, VZ name not updated. Of course, I have not added this PV to any VZ, so nothing was given. That PV size is 1 GB, and PE size is no allocated, nothing allocated. You'll see once it was allocated to VZ. Okay, this so PV is created. Next, we need to add this PV to VZ by using VZ create. So here I am using VZ create because I am creating a new VZ. So for that I am using VZ created. If already VZ was created, then we will use VZ extend command. Okay, we'll see later. Now I am naming my VZ name as my VZ. Okay, or use VZ1. I am naming my VZ name, volume group name is VZ.